is webinar number 2 in the URC webinar series hosted by Protocase. And also a special thanks to those teams who did end up watching our webinar introduction to Protocase that happened a couple of weeks ago. We're already starting to see teams send in their designs, so we're quite happy to see that, so thank you. And you guys would already have the files, the webinar files and the presentations already for that too, so that's good. Today, guests definitely do not need any introduction. The topic today is going to be preparing for the system acceptance review with the URC judges. So this is going to be your opportunity to hear the judges discuss what they're looking for when evaluating reports, and we'll have some time at the end for questions. So without further ado today, I want to welcome Kevin Sloan and Darryl Robertson to the webinar, and you guys take it away.
All right. Hey, thanks so much, Chris. Thanks to Chris for helping to coordinate this. Thank you to Protocase for hosting this this webinar series, and of course for their continued support of URC and all the teams. So my name is Kevin Sloan. I'm the director of the University Rover Challenge. Darryl Robertson is joining us as well. He's currently on by audio only. We're fighting through a couple of technical issues. We're going to see if we can get him on by video as well. But if not, he is here and will be chiming in as we go along as well. So we're really excited. There we go. See Darryl popping in on video. So he'll be with us as well. Really excited with what we've been seeing from the team so far this year. This has really been a great year. We have teams from 16 countries this year, which is a record. 93 teams total started out throughout the year. Still have a great group of teams competing in this SAR. So the system acceptance review, that is our next big milestone for URC. It's really opportunity for teams to showcase where you're at, what you've been working on that's really unique and is going to set your team apart. I think everybody knows the SAR, that's our last big milestone before the URC finals. And that's actually the process that we use to select the final 36 teams that will end up traveling to Utah to compete in the finals. We know there are a lot of teams doing incredibly great work. There's definitely more than 36 awesome rovers out there. Unfortunately, the logistics out in Utah only let us bring those 36 teams. So it really does put the pressure on teams to prove that you are one of the best of the best. So today we're going to walk through some of the SAR requirements. We're going to give you a little bit of context from the judge's perspective so you can understand what we're looking for as we go through the report and the video. And certainly if there are questions about the SAR, URC in general, certainly encourage teams to submit those questions. There is a question and answer Q&A button down on the bottom. You should be able to submit any questions through that as we go along. We'll do our best to answer those. All right. So Darryl, you're online. Anything before we get started here?
No, go for it.
All right. Let's dive on in. So I'm going to start by switching over, sharing a bit of my screen here. And teams should be able to see the URC website. So urc.marssociety.org. If you go under team info, system acceptance review, that brings up our SAR requirements page that talks about everything we're expecting out of teams. Hopefully that's not news for anybody. Hopefully everybody has already been there and is pretty well familiar with the requirements. So again, we'll start off with some of the logistics. So your SAR reports are due on the evening of February 28th by 11:59 p.m. So the very last minute of the day on February 28th. In URC, since we do take place in Utah, all of our official times are in Mountain Standard Time. For teams that are or aren't familiar with daylight savings time, we are on standard time right now, so that is UTC -7. So pay attention to your time zones when you're submitting those. There shouldn't be any reason for anything to be submitted late. And please, I'm begging teams, please do not wait until 11:55 to go looking for that form submission email, only to discover you have a technical glitch or waiting for YouTube to process your video, because there's always teams who are trying to get YouTube to process their video. It takes YouTube time, so don't wait until 11:55 p.m. to start uploading everything. If you do that, you're going to be in trouble. Start everything at least 12 hours early. Make sure there are no technical glitches there. All All right, so that submission form that I mentioned, teams do not yet have that link. I was going to wait until we got through this webinar today, and then I'll send that email out to teams, probably through the URC announce list, so that everybody will have that submission link. Similar to the PDR submission, it's going to be through a Google form online. All you need is a Google account. It can be anybody from your team that uploads that information. Again, I said it once, but it bears repeating again. This is a competitive milestone. We're not assessing your team strictly based on your own merits. We are comparing all of the teams, and you are being scored against each other. This is a competitive milestone. So every team receives a score, and only those 36 top scoring teams will be invited to the 2020 field competition. So again, there are two components of the SAR. There is a SAR report and a SAR video. These two pieces, or these two submissions, the two different formats, they really are supposed to be working together. It's really important for the teams to think through what information you are presenting and how you can split that across the report and the video. So think about things that are best shown in video. Think about things that are best communicated through a written report. So again, just working through the everything that's written on the webpage here. Something that's important to emphasize to teams is that all content not created by the submitting team has to be credited and cited appropriately. This includes stock images. If you want to show us a picture of a Jetson TX2 because you think we haven't seen one of those before and it's going to add value to your team, make sure that you cite that. We know when teams are using stock images, and it's important. If you were using an image that your team did not take the picture, if your team did not generate that image, if it is from a third party, it is up to your team to cite that appropriately. That's a very serious issue. Now, something minor like a stock image you might not think is a big deal, but this becomes a slippery slope, and we see teams leveraging lots of information or lots of other third-party provided material, trying to pass that off as their own. So there's something that we take very seriously. We treat that as plagiarism. There will be deductions of points, even for something as simple as a stock image that does not have an appropriate citation. So something to keep in mind. This is an extremely competitive milestone, so there's no reason for teams to lose any points on easy issues like that. So moving into the written portion of the SAR report, so that is a 6-page report. A cover page is optional. If you include a cover page, that does not count in your 6-page limit. That can be a mixture of text and graphics. There is no restriction or no guidance on how you should be balancing text and graphics across those. Again, it's up to the teams to convey that information appropriately. Some of the format requirements, so we're looking for standard letter paper size with 1-inch margins. Text should be the equivalent of Calibri 11-point font. It can be a different font. Just make sure that it's about the same as Calibri 11. We just want to make sure that nobody is submitting anything unrealistic, trying to cram in more text than the space really allows. Electronic submissions are required in PDF format, so we require everything to be in PDF format. It's important that you submit it that way. PDF is very good at verifying we are viewing the report in the exact format you intended to submit it. We have noticed issues with documents in DOC or DOCX format in the past. They don't always display on the computer the way teams intended. We don't want an issue with image formats and buffers to bump you to an extra page that would result in a penalty. So again, PDF formats are required. When you go to the form to upload your report, it only accepts PDF file formats. All right. So out of those 6 pages, there are 2 pages that we have very tight restrictions on what is to be included on those pages. So page 5 of your SAR report, that is required to provide an up-to-date Gantt chart as well as your team's budget. So there is no other information that should be on page 5. and that's the only place that these items should be presented. So teams should have a Gantt chart, and you should have a budget. Let's talk for a minute about Gantt charts. So Gantt charts, and we even have a question a little bit further down about Gantt charts. But your Gantt charts, we're looking for a decent amount of detail when we go through those. And I'll find the reference here in a second. I believe the minimum time frame that's required in the Gantt charts is December 1st through May 30th, the end of May. Hopefully Darryl, yeah, here we go. So your Gantt charts must be at a minimum December 31st through May 30th. We want to make sure that teams are thinking all the way through the competition, and we want to see teams documenting the work that's been completed to date. With Gantt charts, those really should be conveying a decent amount of detail to the judges, and more importantly, your Gantt chart is really a reflection of the systems engineering approach that your team is taking. Your overall thought process as you're going about the design process. In the PDR, we focused heavily on your project management plan and systems engineering throughout the system development lifecycle. We want to see that really reflected in your Gantt chart. So we want to see that teams have an appreciation for the different subsystems, the timing required for the different subsystems to progress through their design, development, fabrication, and then integration at the system level. It's more than just, we have a mechanical section, we're going to design it, build it. There's an electrical system, we're going to design it, build it, and then there's a 1 week window at the end where we're going to integrate it, and then 2 days to test, and then we ship to URC. That's an example, is a very poor example of a Gantt chart. A Gantt chart like that hasn't really thought through some of the systems engineering impacts of integrating subsystems, being able to go through an iterative testing process where you were testing things as you build them. You were testing at the component level. You were then testing at the subsystem level. And then you were testing at the system level as you were going through these multiple levels of integration with your system. Again, I focus on this in the Gantt chart. We're going to be looking at this throughout your report and making sure that your team has this philosophy really baked into your project management structure. But the Gantt chart is really an extraordinary place to be able to showcase that you have thought through this, because that's where you lay out on the calendar when you are working through each of these tasks and showing judges that you are committing and devoting time to each of these. Another thing to consider with Gantt charts is Gantt charts should be up to date. We're going to look at the progress your team showcases and know that that's where your team is at the end of February. Judges are then going to look at your Gantt chart, and we're going to make sure that those two things match each other. So if your Gantt chart says that you're going to focus on system level testing by the middle of March, but you're only showing us videos of initial fabrication of the frame, we're going to see that your team is behind schedule and that your Gantt chart hasn't been updated. So these are things for teams to really think about. That Gantt chart should be as accurate as possible and should really be a reflection of your team's design processes. The other component of page 5 is an updated team budget. Now, we realize teams are in different scales. Teams, in some cases, have a lot of different activities. Teams may be competing in different competitions. So what we are looking at for the budget, we're looking at the budget in terms of the rover that you were fielding for the University Rover Challenge, and we are looking at whether or not your team has the travel budget to support traveling out to the University Rover Challenge. Those are the primary things that we're going to be looking for. If you have a separate travel budget dedicated to the Indian Rover Challenge or European Rover Challenge or CERC in Canada, those don't need to be included. That is out of the context of URC. If your team does a lot of educational outreach and you have a $2,000 budget for that, that's great, but that's not something that's imperative to include in your budget for the system acceptance review. So again, we're looking to see what you are forecasting in terms of your budget requirements, what budget you will need to have accrued to complete the project, including travel. We want to know the funding that you have raised to date. And if there is a delta, if you require more funding than you have raised to date, we want to understand your fundraising plan to close that delta, to raise all of your funds on schedule and make sure that that balances against your Gantt chart and your progress to date. If your team still has 90% of your fundraising left to do with the SAR, but your Gantt chart says that you should be 90% of the way through your work, we're going to see a mismatch there, and that's something that the judges are going to question. All right. Now, page 6 of the SAR, that is exclusively for the SAR science plan. So science plan should only be discussed on page 6. And page 6 shouldn't have anything other than that science plan. All right. So question that just came in, it's hard to fit a meaningful Gantt chart into a single letter-sized page, even without considering leaving space for the budget on this same page. Excellent question. With the Gantt chart, so for any images or figures, you don't have to follow that same font size restriction, so the Calibri 11-point font. You can develop a high fidelity, high resolution Gantt chart. You can treat that as an image, and you can compress that image to fit down on a portion of the page. The judges will zoom in on the PDF to view that. The important thing that you're going to have to look at is to make sure that that image compresses correctly so that we can still read the text. If you can zoom in on the PDF you submit and read the text, then you've done your job. Now, some teams have incredibly detailed Gantt charts that would fill up pages and pages. So it's up to the teams to think about how you want to condense that information so that you can convey that system level context. It can be done. We understand that only one page of information is required for both the Gantt chart and budget. So the judges do have that in mind. So we're not going to expect to see a 300-line work breakdown structure reflected in your Gantt chart. That's not realistic for the size constraint. At the same time, if you have a 12-line Gantt chart consisting of 4 subsystems with design, fabricate, test, again, that's kind of the opposite end of the spectrum where there really wasn't enough detail put into the Gantt chart. So I hope that answers the question. All right. So I'm going to skip over the SAR video at the minute for the moment, and we'll come back to that. All right, so we talked about pages 5 and 6 of the SAR report. So now let's talk a little bit about pages 1 through 4. That's really the part that is unstructured for teams to cover a good deal of information. Now, the SAR report content that we outline on the website here, there are a lot of requirements baked into these paragraphs here, and it's up to the teams to make sure that they are addressing these requirements. As you were going through and looking at everything that we have written here, I would start to think of this like a checklist. And that checklist for your team, make sure that you've addressed those systems because everything that we identify in the writing here, that becomes our scoring rubric. So everything that you see written out and listed, again, that is the scoring rubric that we're using to assess your team. So we do require, in a minimum, the required elements below. Teams need to really be thoughtful on what the appropriate level of detail to convey on each of these items is. And it's important to understand where you are really conveying information that is appropriate. So one example that we give here, we've seen a lot of teams in past years that really they'll spend a half page on a fundamental premise such as explaining the merits of 6061 series aluminum, getting into one very niche design trade that basically every team goes through at some point. And everybody that's been through college engineering has talked about the benefits of aluminum versus steel versus other materials. We understand that a topic like that is going to be one of many trades your team's going to go through, but spending a half page on that is not making effective use of this space. So again, avoid falling into some of these more these more elementary topics and focus on really the big, meaty discussion topics that we'll address below. So one of the big thematic areas, your core rover systems. When we say your core rover systems, we mean the parts of your rover that are going to be essential to competing in each of the 4 mission areas. Your rover is going to have different modules that you may be bringing on or off of your rover, but the core rover systems is talking about the frame assembly, the suspension, the drive system. Communications is an important part of it, so it's more than just what's fielded on the rover. You're going to require a communication system that interfaces with equipment not on your rover. And then the other piece of it as well is the command and control system. So the command and control system where your team is operating, don't let that be a forgotten topic of your overall system. The interfaces, the systems where your operators are actually driving the rover, that is an essential part of every mission that you'll be competing in at URC. And not addressing it in the SAR, it's a missed opportunity. And even more importantly, in terms of being prepared for the competition, if you haven't thought this through in an appropriate manner, it's a missed opportunity for your team to be that much more effective in how you control your rover. A great rover with a terrible interface is really just a system that won't operate. As you're going through the core rover systems, there are more systems that you will want to talk about than you really have space for, and the judges understand that. So we want you to focus on the subsystems that are either high risk or unique to your rover. So we don't always need to know what gauge of wiring you're using or how many different colors of wire you have. Really focus on the things that are important or unique to your team's rover. So see, there is a question there on programmatic score, so I will get to that momentarily. All right, so approach to the competition missions. So teams should be describing their systematic approach with subsystem plans and how the subsystems are tailored to each of the competition missions. So this is really an opportunity to focus on each of those missions that the rover is required to perform in the field, and let us know what specific subsystems on your rover are unique to accomplishing those missions, why you made the design choices that you did, and what is going to set your team apart. Some teams will take the opportunity to get into a discussion of requirements here. We don't want to see your team spend an entire page doing a requirements decomposition process, but at the same time, understanding how your team has thought through requirements, there is some benefit to that, and keeping everything kind of within a reasonable scope. The one exception here is your team's approach to the science mission. That should be limited to the SAR science plan on page 6. So testing and operations. So I talked a little bit about testing and operations before, so we want to know that the testing that your team has completed to date and what your plan is to complete testing throughout the competition. So this, again, is something that should be reflective of your systems engineering approach. So are you testing at the individual component level first, and then progressing through subsystems and then your larger systems, and then ultimately culminating with operational testing and training. Operational testing and training is more than just running the entire system in the lab. Your rover operating in a safe lab environment where you've been working all year, that is an important milestone, but that is very different than how you will operate at University Rover Challenge if you're one of the teams that's invited. If you are coming out to the University Rover Challenge, there is a much larger logistics process that involves taking everything that you've built on over the entire year, packaging it into shipping containers, physically transporting all of that equipment to a new location, getting into a new environment, unpacking everything, setting things up to operate in this new environment. There is kind of an operational testing aspect there that is more than just your engineering systems, but is understanding how your team will operate when it is in the field at URC. That's something that we love to see. Not many teams will have gotten to that level by the SAR, but certainly the SAR is an opportunity to talk about what your team has planned there. The operational testing as well. Have your operators been testing using the real interfaces and controls that they're going to be using in the field in Utah? Have you been testing outdoors in different lighting conditions? Have you been testing on different types of terrain, going over different obstacles, whatever you have available? So those are things that the judges are really looking on there. And really the thoroughness of your testing plan is a direct reflection of how thorough your team has been throughout the systems engineering aspect of this. All right, so there's a question here. Should the science plan also contain a description of the mechanics of soil collection, or can that be addressed within the other 4 pages of the report? So anything specific to your science payload should be addressed in the SAR science plan on page 6. The other place that this comes up is in the video. So your team is also encouraged to demonstrate the mechanics of your science and sample collection payload in the video. But to ensure consistency among the teams, we're really looking for that scientific explanation to be reflected in the science plan. Switching back over to the website here and the SAR requirements. So we talked a good deal already about page 5 of the SAR report with the Gantt chart and budget. Page 6, that science plan. So that should really be describing the tests that are going to take place on board the rover and how your teams are going to be able to distinguish between extinct, and no life with the onboard life detection systems. So your team should be talking about the system that you're going to build, the physical, electrical, mechanical system, and then you should also be talking about the scientific basis behind why you chose that type of payload and how it will work, again, in the science realm. The science judges that evaluate the science plan have a background in field science and astrobiology in particular, so you need to keep that in mind when you are preparing that science plan. There was a question earlier about the programmatic score. So in terms of programmatics, it's really tied to everything that you see reflected that we just went over. So everything that's written here becomes a different scoring component. Programmatic score is going to be driven largely by your Gantt report, or your Gantt chart and your budget chart, and also taking a look at your team's level of progress to date. Question coming in, do we need to prove that we fit in the size requirements in the report? So this is something that certainly teams are encouraged to quickly address. We don't need you to spend a half of a page or any long explanation explaining why you fit in the size requirements. If teams are inclined to quickly address it, whether in the report or the video, great. Otherwise, it's a requirement. That is a black and white requirement, so we're going to assume that teams are adhering to it. The only other case where I would really encourage teams to take that into account, if it is not completely obvious that to judges that your rover can fit in that size requirement. So when we're looking at your video, we'll have a pretty good idea just from watching the video if your rover is on the smaller end or the larger end. If you have a rover that's nice and compact, it clearly fits within that 1.2 meter box. That's not something you need to spend a lot of time addressing. If you have a rover that is going to have a lot of articulation taking place after the measurement, where in its fielded configuration it's a little bit bigger, but it requires, again, kind of that origami effect where it folds in on itself to fit within those size requirements, that is something you're probably going to want to address. And again, a lot of that really comes down to put yourself in the judges' minds. Think about the information that the judges have in front of us when we're going through the report and video. Think about what our perspective is and where we might see concerns. So if you have a rover that's clearly 1.5 meters long, you should understand judges are going to know that that's an issue. So hopefully you would have addressed how your rover is going to do that articulation. All right, question coming in, how to interpret the concept of high-risk subsystems? Well, that is an excellent opportunity for teams to demonstrate your thoughtfulness and your awareness of the subsystems. So as we're reading through what you're implementing, we'll have our own impressions of what we think is high risk, but really you're going to prove your team's really overall readiness and thoroughness in this review if you can demonstrate to us what you think the high-risk subsystems are. If you identify the same high-risk subsystems that the judges identify, you're probably doing something right. So again, that's something just left to teams. And there is no right or wrong answer there. So there's not a magic box of high-risk systems and a magic box of systems that don't have any risk. So it's a continuum, and a lot of it is relative to the overall system-level architecture. So it's something where your teams have the most intimate knowledge of your rover. So that's really where you can provide your unique insights to your rover and how you convey that information. All right, switching over to the SAR video. So the requirements that we talk about above for the report, those really are the primary evaluation criteria. The only other thing that's not documented in there is a judge's assessment of your overall level of readiness. So the judges are providing a score. It is our own assessment as we watch the video and read the plans. Do we think that your team is really going to be ready to compete at the end of May? So that's just one additional criteria for teams to think about. But of those other written criteria that show up in that report section, we're really looking for your teams to address this across both the report and the video. And this actually speaks to the question that just came in. Can you give us an idea of the relative weighting of the video and report? The simple answer is no. And it's not because we don't want to answer that question. It's because there is no concrete separation of a report score versus a rover score. Again, I just walked everybody through the scoring criteria. So if teams can't build their own checklist of the scoring criteria at this point, I really encourage you to keep reading this page over and over and over again. But we're looking for that to be demonstrated across the report and video. So the video is really your opportunity to showcase what your rover has done. So we're looking for you to expand across, we're looking for you to expand upon what was in the report. If there's anything that wasn't fully conveyed there, we're going to be looking for an extension of what you've been communicating in the report to see consistency through the action that you show in the video. But really the most important thing that you can convey in the video is demonstrating your rover's progress and overall capabilities. Demonstration of your rover is without a doubt the most important thing that you can do across the report and video. Now, what I said earlier still holds true. There is not a separate score for your report. There's not a separate score for your video. But at the end of the day, what you demonstrate in terms of your rover's level and your team's level of readiness in the video, that is one of the most effective forms of communication throughout this entire SAR process. All right. Throughout the video, we are going to be looking for what your teams can demonstrate in terms of readiness for each of the 4 competition missions. So think very closely about that. That's not a set requirement. So originally, there was no requirement on how much teams were expected to be able to showcase through demonstrations in the SAR report. And some of this is because this is a competitive milestone. We're setting a line at the top 36 teams to see who's going to make the cut and who doesn't. So really, the extent of what you have to showcase is based on the performance of the other teams in this competition. Now, historically, especially in recent years, as the field of teams has gotten stronger and stronger, we've seen that teams are demonstrating very well-integrated systems by the SAR. So we're looking for what your teams can do to showcase readiness in each of the different mission areas. Some of the other things that we're looking for. So if you think about your overall rover mobility, obviously we want to see that you have a rover that can drive, can move, can turn, but then we also want to see you take that a little bit further. Don't just stick to driving on the floor inside of a building. We want to see what you can do outside in different terrains over different obstacles. Now, I know we've gotten questions in the past from teams that live in colder climates where they're still dealing with snow. Get creative. We've seen rovers driving up snowbanks before. Realize not all rovers are really able to withstand that. We've seen rovers driving over snow obstacles. We've seen rovers driving over man-made obstacles inside. So you can make your own indoor obstacles to showcase what you can do. But I would encourage you to be as creative as possible and really showcase what you can do against different types of obstacles and different types of environments. And to the extent that you can showcase your rover working in different types of terrain with, whether it's loose soil or driving over rocks, the more diversity you can demonstrate there, the stronger your team's entry will be. Showcase what your rover can do with its manipulator. Now with the manipulator, I think it's important for teams to think about what you're showing the judges in the video. Now I'll give an example of something that hasn't been effective in the past. If your team is showing a video where you are zooming in very closely on the end effector of your rover and you show us your end effector opening and closing, but we can't see anything beyond just that end effector, we're going to assume that your arm isn't working and you are holding an actuator in your hand and you are holding that end effector and just showing us that last little bit right there. So the more of the overall system you are able to showcase, again, the stronger your video will be. If you show us your entire arm fully integrated on your rover with every single degree of freedom being actuated and implemented, that is great. If you can show us actually picking up picking up items or accomplishing dexterous manipulation tasks that are representative of what you will be competing in at URC, that's another strong step in the right direction. Even better, if you were showing us that arm integrated on the rover being operated by an operator and you show us the interface that they are working through, that is kind of that end state where you are showing us every part of the manipulation system, which includes the student operators. So again, it's all about the different perspectives, whether it's component, subsystem, system level, or even at that macro level where it includes the human operators. All right, so there's a question that just came in. Can you briefly explain the evaluation criteria of the SAR report and video? So I will simply say to that attendee that has been the topic we have covered for the last 40 minutes of this video. So please go back, watch this video again. Please read that page. That has been everything that we have been talking about. So please take that all into consideration. All right, your science, your team's science payload. We're looking to see how far along your team has come with implementing the various electromechanical systems, how that's going to work there. Some teams might get into how you're going to conduct a laboratory analysis. That's good as well if your team, elects to include that information. You probably don't need to spend 2 minutes out of your 5-minute video focus solely on that. It's not to discount anything from the science. It's just there's a lot that the judges would want to see from your team throughout this video. So make sure that everything is kind of scaled appropriately for the overall amount of content you want to show us. So we've got a note here. some recommendations about the video content. So this is a good opportunity to remind teams. This isn't just true of the videos, but the reports as well. So the judges are all professionals with technical backgrounds. Amongst the judging panel, we have many, many decades of combined experience evaluating student rover projects. A lot of the URC judges have been at this a long time. We know what we're looking for from teams, and we're really looking for teams to get into that technical detail, showcase the information about your rover that really shows us a great technical presentation. We've seen a lot of what we call the overly embellished marketing style videos or the Kickstarter videos. Those are great promotional videos. Encourage your team to build those and use those for general marketing. Those are not received very well by the judges. If you have a lot of flashy graphics and great audio that take up half of your overall presentation, again, it's a lost opportunity to convey technical information. All right, now the video is limited to 5 minutes in length. I would encourage teams, make sure that you've uploaded your video to YouTube ahead of time. Look at the length of the video in YouTube. If your video is 5 minutes even on your computer, when you upload it to YouTube, once it goes through that conversion process, it might end up being a couple of seconds longer. So that's something to be very careful about. One question that we always get, if your team builds a 5-minute video and you have a freeze frame at the end that's just an acknowledgement to your sponsors and that runs to 5 minutes and 5 seconds, for example, that is completely fine. The content of your video should end at that 5-minute mark though, 5 minutes and 0 seconds. Judges will stop watching there. So again, if you have a freeze frame thanking your sponsors that lasts longer, that's fine, totally acceptable. If your team keeps talking after 5 minutes, we will start deducting points though. All right. So if your team, question that came in, if your team has submitted SARs in previous URC competitions, do you look at what's been improved or changed? Or do you give teams a clean slate of judging irrespective of previous years? That is an excellent question. Thank you very much for submitting that. In general, we are looking at your SAR report in a vacuum. We assume absolutely no external information at all. We don't care if you competed in URC last year. We don't care if your team just won the Indian Rover Challenge or you won the European Rover Challenge last fall. Those are great accomplishments if your team has achieved those. But again, we are looking at only the content that is communicated on your report and in your video. Never assume that the judges remember anything about your rover from last year. If you're relying on components of your rover from last year, you need to revalidate those to the judges. We don't care what happened in 2019. We care about your 2020 rover and only within the context of URC. So again, when you are going through and reading your report, looking at your video, I would encourage teams, actually find a classmate, find somebody who is outside of your team. Ask them to review the report and ask them if they have any outstanding questions. It's easy for authors to assume a certain level of knowledge from the judges or the outside reader going in. And you want to be very careful about that. Never assume that the judges will give you credit for anything that isn't written on the page. All right, question coming in about a very detailed scoring document. So at the end of the SAR milestone, we do have an evaluation report with all of the scoring and detailed feedback that we send to each of the teams. So you'll see scoring breakdown based on all the criteria that we've already run through. All right, what do teams participating for the first time lack generally? As we haven't seen teams qualify on the SAR in their first attempt. All right, so again, another excellent question. URC is a very difficult competition. We really are throwing a lot at the teams, and the scope of the task is an extremely tall order, and that's something that we acknowledge. It has become very difficult over the years for teams to make it through in the first year. However, that is not an absolute. So we've had teams each year that have made it in on their first year attempting. Not always the case, though. A lot of times teams will have to go through the process and will have had to have been building up their resources over the course of 2 years before they really are able to hit that milestone. And a lot of that is just based on the overall scope and magnitude of the competition. So that's something that we realize. It's something that the judges really do think about very seriously. And we certainly wish that we had an easier answer to address that. But for teams coming in, if this is your first year, if this is your first year, really put everything that you can into the SAR milestone. Give us everything you've got. You might make it through, but if not, use this as a learning milestone. Use this milestone as an opportunity to drive your team all the way through this milestone, get as far as you can. When the feedback comes, if the feedback isn't what you were hoping for, use it as an opportunity to learn. That doesn't mean that your team has no hope. Lots of teams have missed the cut 1 year and had to keep working at it before eventually qualifying. So just keep focused, keep working. There are lots of other competitions through the Rover Challenge series that are great opportunities for teams, especially newer teams, to get experience, whether it's the Canadian International Rover Challenge, the European Rover Challenge, the Indian Rover Challenge. There really are opportunities everywhere. So encourage teams to just keep working. And I promise if you stay with this project, you're going to learn. You're going to become better engineers, scientists. You're going to be more thoughtful project engineers as you move forward in your educational careers and really into your professional careers eventually. All right, so a question, can we show prototypes and simulations in the video, or can we only show components that are fully working? So kind of two different questions within there on prototypes and on simulations. Simulations absolutely encouraged. Simulations can really be used to showcase your overall design process and what you were able to accomplish there. Also, simulation ends up being a good way to showcase what your team has been able to accomplish with the autonomous traversal mission. So use that to your format, but judges are going to be able to tell if you're relying too much on simulation to make up for the fact that you don't have systems physically developed. On the prototype phase, the same goes for prototypes. But if your team is showcasing something with a prototype, you really should be disclosing to the judges, this is a prototype system. And then you should be showing teams through your Gantt chart and your overall approach how you were using the knowledge gained by working with that prototype to feed into your overall system. So we're going to give it that system level context. Yep, so there's a question that just came in about programmatic score. That's a question that we addressed a little bit earlier. That's really largely based on your Gantt chart and your finances. So everything that's on page 5. Those are the biggest points to convey from that. All right, so if you're looking on the web page, so there is a note about hazardous materials. So for the science mission, if your team is planning to use any hazardous materials, you don't have to give us a detailed safety plan in the SAR. You should start to identify those if you know them, with just a note that a full safety plan will be submitted. Closer to URC, there is a final science plan that has to be submitted, and that would include that full safety plan. So we have other information on the website that talks through what to consider if your team is going to be working with hazardous materials. In general, teams are highly discouraged from using hazardous materials. It is very rare that we see teams working with highly hazardous materials where that is adding value to what your team is doing. All right. We have a number of questions and answers that are included on the webpage as well, so it should provide some additional context for teams. All right. Hey, Darryl, from your side, seeing some of the questions that have come through and anything else, anything that you want to highlight to teams?
Yeah. Can everybody hear me?
Yes. Yeah, you're good.
Okay, great. Yeah, I've got a little list of stuff I've made as we go along. And I can just go over that quickly if that sounds good at the moment. So, I don't know, the main thing I wanted to give first was also like a little brief overall, and that the PDR and the SAR are kind of modeled on a sort of like stripped down version of like a U.S. government acquisition program. So, you know, you guys started off in the PDR by giving us something like a proposal, you know, hey, look, we want to build a Mars rover, and you guys go out and say, yeah, hey, we could do that. Here's some prior experience we've got, and here's the rover we'd like to build. And at this level, for the SAR, it's basically the down select. Like, who are we actually going to pick to like build this system? And this is something, if you guys go out into industry later in your careers, you'll go through this in you know, multi-year programs, and be writing proposals and design reviews and stuff like acceptance reviews, and to basically move the system along. Now, I mean, obviously, we stripped that down a lot. And the main thing in the SAR is to get across to us why we should pick your rover to go out to URC to compete. And that's really what you're trying to get across. You know, if you're getting bogged down in the weeds and some of this stuff, just think about what you would want to see. The best thing I can probably suggest to teams who aren't quite sure what to put in the report, what to put in the SAR video, is to go and look online at previous SAR submission videos. You can look up, YouTube's got a whole bunch, for example, and you can watch their videos, and you can also see how well they ranked. You go and look up scores for like the last few years, or sort of that, just, you know, how well the team did in general. And there's generally a correlation between the quality of the SAR videos and the SAR scores and the final scores at the end. Obviously, there's always a few teams who are, you know, dark horses, who typically a lot of the novice teams and the teams who haven't been doing it for 5-10 years. And then also there's always, you know, 10-year veterans who have something break on the first day of URC, and you know, that crashes them out of the competition. But go and look at previous videos. Decide for yourself what you think their quality is, how you would judge them. Somebody mentioned earlier about like a detailed scoring mechanism. We don't treat this as a checklist, if you like. We don't just have a big old checklist and you just want to check every single box. That doesn't mean we don't have a list, but we don't put the scoring directly on that. You know, there's 1 point for this and 2 points for that and everything. Treat it a bit more holistically than that. You know, decide what you think best shows your rover. There's kind of a trade-off here, if you like. Some of the judges work in more operational environments. They place more emphasis on fully operational systems, on readiness, basically. And other judges work in a more research and R&D environment, and they're more interested in seeing you guys push the envelope of what we've seen out at URC and, you know, what you can do in robotics in general. So, as I said, there's a trade-off there. If you guys are all coming with, you know, a rocker bogey system and an off-the-shelf Wi-Fi and a 5 degree of freedom joint-by-joint control manipulator or something, you guys had better have that really ready. You need to demonstrate that performing all the tasks well. If you've got a highly novel system with a lot of customization, a lot of stuff you guys have done from scratch yourselves, and it's not something that we see every day on like 30 rovers in the SAR reports, you're going to get a lot more points for that, and even at the expense of perhaps of the readiness. So for example, readiness is certainly important, and but we don't need to see everything necessarily integrated on the rover. But the more stuff you can show is working, the better. A lot of people asked about the weighting between the report and the video. The one thing I would say in the video is demo. Demonstrate everything that you can. Show it doing as much as you possibly can. Save the long discussions for the report. Keep the video on showing the rover doing stuff and showing it doing as much as possible. Show the rover climbing stuff, not just driving down stuff. Show the rover, picking different things up. Show it picking up heavy things. Show it doing fine control manipulation. As well as the list that's in the SAR report, you guys all have the rules, right? And there's a whole big list of subtasks there. Go through every single one of those subtasks. Show me the rover typing on a keyboard. Show me the rover turning a knob, flipping a switch. Every single one of those things. The more you can show, the better. And then save the other stuff, the discussion stuff. Save that more for the report. It's going to be my honest suggestion. Doesn't mean you have to do it that way. Whatever you think best showcases your rover. Like, why should we, pick you guys over somebody else? It's basically what it comes down to. And the more that you can show there, the better. Somebody mentioned the folding size limit. Like, if you've got a origami telescoping fold-out rover that fits within 1 square meter and then balloons out to a 2x3 meter square, please, for heaven's sake, show that. Show it working, because that would be really cool, and we'd love to see it, and you'll get lots of bonus points for that if you like. Let me see what else. Okay, so a couple of other things here. Outreach. If you do outreach, please show us some. It doesn't need to be more than 10, 20 seconds or whatever. Just show that you did some. It's worth a few points, or at least talk about it in the report or something, or throw in a photo or something. We are interested in seeing that you're doing it, but as Kevin already said, that is not the focus here. The focus here is on how well your rover does, but you can get a few points by including it. Okay, 2 other topics. Science. In the video, if you can show us or explain how the stuff works, that's useful, but it's not the main focus. In the video, we're most interested in seeing it happen. Whether that's like the scoop picking up some soil and dropping it into whatever experiment that or holder you've got on the rover, or maybe that's still on the lab bench and you can show the experiment taking place on the lab bench because you haven't integrated it on the rover yet. But I mean, show us like the mechanisms, if you like. The science and the description of the science and why you picked what you did and how it works and those details, that should absolutely go in the science plan. If you put anything on science outside the science plan in the main report or in the video, in the science plan, tell the science judges where to go find that. at, at minute 4 in the video, or, wherever you've put stuff, tell the judges where to go find that, so that they don't miss it, because the science judges are going to probably start by reading the science plan. The engineering judges are probably going to start by watching the video. Okay, 2 other topics. First one is prior experience. Unfortunately, we have had an issue with several teams in the past. They have a great team, they have a great rover, and then all of the key people graduate and leave, and the team next year just falls apart. So consequently, that is probably the main reason we don't put a lot of weighting on your prior experience. If you can show us, like, a video clip of the rover working out at URC last year, that's fine if you want to include that, but make sure you do include some video of it working at your university or whatever this year. And in particular, if you're not making a lot of changes to the rover, tell us about what you have improved. Tell us about why your rover is better than it was last year, what systems you've worked on, what changes you've made, and point that stuff out to us. And show us, like, we talked about snow and whatever in indoor tests. Show us the rover doing some stuff at your university and the testing that you've done there. Showing that you've competed in another competition is fine, but we really want to see what this year's rover can do, right? And how is it improved over last year's is where you should put the emphasis. Okay, and I've got one final topic here. As part of the rover challenge, we have the Indian rover challenge, the European rover challenge, the Canadian rover challenge. We've got like 90 teams, and we can accept 36 here. If you don't end up passing the SAR for URC, apply to one of the other competitions, and if not this year, then next year or something. Keep working on the rover and come back and learn. This is a learning experience, right? That's the main goal of URC, is an educational experience. All right, Kevin, got anything else?
Yeah, so I know there are a couple of other judges that would certainly not be happy with Darryl and I if we didn't bring up one of the one of the biggest issues that can really hinder a team's video, and it's ultimately a trivial issue, but it comes down to the audio quality in videos. So the audio quality in videos is extremely important, especially if you have team members that are talking. So one of the things that can really hamper that, if your team is using music as part of the video, a lot of things can go wrong there. So if you don't actually spend time balancing the audio levels in your video, you can end up with music that is drowning out any of the speaking, or if the music is just too loud and it's at a different time from when speakers are speaking, judges have to turn down the volume because of the soundtrack, and then when your team is talking, judges don't realize that your team is talking because we had to turn the volume down. So there's a lot that can go wrong with adding music to videos. There's not a requirement that you can't use music, but let me just emphasize, a lot of things can go wrong if your team is trying to put music in your video. So unless you have really spent a lot of time doing good audio engineering, in which case I have to ask, why are you spending your time doing good audio engineering and not working on your rover? That's something that can really impact the judging quality of videos. We've had a lot of videos that the overall quality of information they convey has been ruined because of music in the background that is simply too loud. It's a very trivial issue, but that's a good way to ruin the quality of your data presentation. With audio in general, spend the time, go back, watch your video, make sure that speakers can actually be heard. If you're not using good quality microphones, or if you're just using a laptop operating in a large workshop, for example, where there's background noise, that's going to impact the audio quality, and that's going to make it difficult for the judges to gather the right information from your video. For some teams, if you're having trouble with audio quality, or if you are non-native English speakers, we highly encourage you to use captions across the bottom of the screen. If you use captions, let us know exactly what you're saying. It's the best thing that you can do to mitigate this risk. The judges do everything we can to make sure that language barriers are not a part of this competition. But at the same time, you can make judges' lives a lot easier if you just if you're able to put captioning across the bottom of the video. So again, that's all about audio quality. And if a speaking component is part of the information you're conveying to judges, make sure that you are communicating that information effectively. Overall, I think we've hit through this a few different ways throughout this this webinar, but we're really looking for data-rich presentations. You have 6 written pages and 5 minutes in a video to cram as much information and data-rich goodness as you possibly can into that video. So use that space and that time as effectively as possible. All right, so a question just came in. Does the unfinished rover design that works as intended during the SAR video affect the rating? So I'm not sure I fully understand that question there. So unfinished rover design, we won't necessarily assume it works. If there is work that you have not yet completed, but you have completed it through the design phase, absolutely encourage you to include designs. Otherwise, it looks like you have failed to address a critical system. So you should show us some level of progress with all of the systems, even if that is a design. However, a good CAD model does not count the same as a fully built, assembled, integrated, and tested system. Those are two very different things, and it is much easier to develop a working CAD model than it is to develop a working system that has gone all the way through integration and testing. Those are two very different things, and they are valued very, very differently, as is true in the real world. All right. Another point that I think is really a good opportunity for teams is find a way to showcase the full extent of your team. Even if you only have one person talking or one narrator in the video, find a way through the video to let us know what the extent of your team is. That can be as simple as a single group photo, or it can be just showing different members of your team taking part in any of the assembly testing process throughout the video. But we really do like to see how you are engaging your entire team. We want to be certain that you're not just limited to a couple of key personnel instead of a fully integrated team. We talked about a little bit about the different missions and what to demonstrate there, but one thing we didn't talk about very much was autonomy. So autonomy can a lot of times be very difficult to demonstrate, but that's something that teams really need to think through, and it really is part of the challenge to teams to decide how you want to communicate progress and your overall design and implementation of the autonomy subsystem. Now, a lot of the different autonomy software packages that you can download have other simulation-based capabilities. There are different ways that you can convey that information. So use those tools at your disposal. You can also show, if you have a video that shows the operators working on computers in the same view as the rover, and you can see where the operators are entering the commands in, hitting enter, go, whatever the magic button is, and then hands up off the keyboards, hands up off the controllers. And in that same frame, we can see the rover actually going forward and completing some sort of autonomy test. That's something that the judges are going to be looking to see. At the same time, judges watch a lot of these videos. We're familiar with a lot of the open source packages that you're all using. So we know what CAN demonstrations look like. We're all very familiar with a lot of the CAN demonstrations that come packaged as part of ROS or everything else. The autonomy you're required to implement for URC is a step beyond those out-of-the-box autonomy demonstrations. So we're going to be looking to see if your team is just, again, replicating one of those basic demos out of the box, or if you have tailored something specific to the competition. And with autonomy, one of the best ways that you can showcase how well your autonomy is working is if you can showcase the system working in a difficult environment with degraded sensor data. For a lot of the visual searches that we're looking for at URC, if you show your rover working outside on a bright sunny day, having to pick up an AR tag in a very occluded environment, that's going to show a lot more capability than just showing that an AR tag being held up in front of a screen in a lab. That is a much more simplistic demo. So your team will get points for everything that you do show, but the more of an unstructured setting you can demonstrate with your rover, the more beneficial it'll be to your team's overall performance. All right. Do we have any other questions from teams? All right, so while we have teams on the phone here, so I'm going to switch back over to a screen share mode. So you saw me working in the system acceptance review criteria page previously. You come over to requirements and guidelines, that's where you can find the rules, but the Q&A as well. So the Q&A has been continuously updated throughout the year. So we really encourage teams on a recurring basis, make sure that you are visiting the Q&A page and you are looking at what some of the more recent questions are. So we have them broken into different categories. For example, rover question 11 is one of the more recent questions that we've received. That one in particular, if we have deployable subsystems such as a radio relay or a mini rover with its own power supply, does it also need an emergency kill switch? So the answer there was any mobile deliverables will require an emergency stop button just like the main rover. So any non-mobile deployables that are using alkaline or lead acid batteries do not require any further safety measures, but a fuse is recommended. Any non-mobile deployables with batteries using any other chemistries will require either a fuse or kill switch. So really it comes down to whether or not it's a mobile system. And then for static systems, it comes down to the battery chemistry that's being used. But when in doubt, it is always better to include a fuse or kill switch. All right. And this is, again, this is up on the URC webpage. There are a lot of questions that come in throughout the year. So make sure that multiple members of your team are reading through this. Don't just relegate this to one person on the team. Make sure all of these question and answer updates are being communicated throughout your entire team so the people working on different subsystems have the right information as they are moving forward throughout the year. Something else that's important to highlight, hopefully teams realize this by now, but autonomous traversal mission questions, number 5, we actually provide you with the real AR tags that are going to be used in the field at URC. So we're not going to be giving you new AR tags. We are giving you exactly the AR tags that are provided in this photo. And you can see the first 3 legs of stage 1 where there will be posts, and then you can see moving to gates in the later stages. So and for the gates, there's one marker that'll be on the left, one marker that'll be on the right, and your rover simply drives down the middle of them. So something hopefully teams have realized that's there. You have everything you need for the AR tags. All right, question just came in. We have a UPS with a small lithium polymer battery on board the rover to allow for graceful shutdown of our computer. Does that power need to be disconnected with the main kill switch? Yes. I think that is important to really make sure that it's clear that the kill switches are not used for graceful shutdowns of any systems. If the kill switch is activated at all, whether it's on accident or intentionally by a member of your team following the rover, or the judges if we feel that intervention is required, if the kill switch is activated, that mission is over. You do not restart in that mission, period. This is a safety issue. So the kill switch is only activated if we see a dangerous situation, such as the rover driving towards a cliff edge and getting ready to take a catastrophic fall, or if we see a thermal runaway situation with either electronics or batteries starting to overheat. Lithium batteries, for anyone who hasn't looked into this topic, lithium batteries can be extremely dangerous if they overheat, if individual cells short circuit. Lithium battery fires are not small. They never end well either. So again, the kill switch is a safety consideration. And the kill switch should be cutting off all power draw from all batteries on board your rover. Understand the desire for a separate battery to allow for graceful shutdown, but that is something that should not be allowed to operate independent of that entire kill switch. And again, it is for overall safety and protection of not just the rover systems, but all of the people around as well in the event of a potential battery fire. We've had batteries start to have thermal runaways in the field before, where we've started to see smoke. We have never had a full-blown fire, and we intend to keep it that way. But and I know I took a very hard stance on that question. Thank you for asking the question. Anything that deals with safety, always ask the question. Sometimes, we're taking a hard stance on it. It's not because we're angry about the question. I'm very glad that you asked the question. Safety is just extremely important. So I need to make sure that everybody is clear on the best way to proceed. All right, well, seeing no other questions, I do want to remind teams, and as I say that, one more comes in. We'll get to that question in just 1 second, but I do want to remind teams that you're always able to submit questions. So if you have questions about the competition, the SAR, whatever that may be, submit those questions to me. It's kevin@marssociety.org, and to Darryl Robertson, that's drobertson@marssociety.org. We're the two best points of contact to send any of your questions to, and we'll get you answers as fast as we can. All right, the question that came in, do you want both power and ground to be cut by the e-stop or just the power rail? We want power draw to cease from the batteries. That's really the end goal. How you implement that within the context of your overall system, I won't get into the nuances of cutting, just power rail versus ground. But think through, and again, I don't want to pretend to give a one-size-fits-all answer. A one-size-fits-all answer is never appropriate, especially if I haven't seen your overall electrical architecture on the rover. It wouldn't be appropriate for me to comment on that. So you really should be methodically looking into that, understanding any potential arcing that could be happening as you were hitting that kill switch. Just, again, make sure that the engineers on your team are looking at this, analyzing it. And again, main intent is to ensure that power draw stops from the batteries. That's the best thing to stop thermal runaway, or at least slow it long enough that we can get a fire extinguisher. All right, so I really do want to thank all the teams for joining us today. Hope that you all found this to be valuable, that you're able to really factor a lot of this in as you're preparing your system acceptance review packages. Again, if you have questions, don't hesitate to reach out to us. Question about internship opportunities at the Mars Society. So that's question, best email to us. We can handle that offline. So again, thanks to teams. Thank you very much to ProtoCase, to Chris for hosting. It has been fun as always. And again, we couldn't do as much as we do for the teams without the support of ProtoCase. So Chris, tip of the hat to you. Thank you very much, sir.
Oh, thank you guys for taking the time to do this. I think it's definitely truth in saying that this is probably one of the more popular webinars that we'll be doing every year, because it seems like the students really love getting a chance to chat with you guys one-on-one. So thank you guys again for, spending the time to do this, and thanks everyone for attending, and, stay tuned for, maybe we'll be doing a few more topics in the next couple of weeks and the next couple of months leading up to the competition. So.
Yeah. Thanks again, Chris. It has been fun. And, if any teams are frustrated that we didn't give you that one golden nugget, or we didn't tell you exactly what the answer should be, the hardest problems in the world don't have right and wrong answers. You have to show value towards inherently ambiguous problems. That is what the real world is filled with. As professional scientists and engineers, you're going to be confronted with that on a daily basis. So we've really tried to integrate that into URC. So if you feel that we're dancing around some of your questions, or that we're being ambiguous in any sense, it's because that's the reality. There is no right or wrong answer with URC. This is a hard task. We really are asking teams to do more than I think any other type of design competition is asking students to do. So it is a great opportunity for teams to showcase what you can do. Kudos to you all. Question about where we can find the link to rewatch the webinar. So we're moving at the speed of technology, but even technology can't keep up with URC teams. We'll get it out. I promise it's coming. Just give us maybe a day or two to get the video downloaded and posted up somewhere. Yep. And with that, thanks again, Chris. Thank you all. And we look forward to reading your SAR reports and watching those videos.
Perfect. All right. Thanks, everybody. Take care.